Hello and welcome to The Explainer. Today, we're going to dive into the history of artificial intelligence. And let me tell you, it's not some straight, boring timeline. It's a story of incredible highs and crushing lows, of huge ambition and massive disappointment. It's a story of what researchers call waves and winters. So let's get into it.
Okay, so first things first. Let's start with a really simple question. Is the whole idea of artificial intelligence new? Something that just popped up with computers in the last few decades?
Well, the answer is probably not what you're thinking. The dream of making intelligent, artificial beings isn't new at all. In fact, it's ancient. Its roots go back more than 2,700 years.
I mean, think about this. All the way back in 700 BC, the Greek myths were telling stories about Talos. He was this giant robot made of bronze, built by the god of invention, no less. And he wasn't just a statue. He was basically programmed to patrol and guard the entire island of Crete. This was one of the very first times we as humans tried to imagine a machine that could think and act on its own.
So here's how we're going to trace that journey. We'll start with that ancient dream. Then we'll hit the first official wave of AI, which was all about symbols and logic. We'll look at the crash that followed, the first AI winter. Then the comeback with a second wave of machines that could learn, leading us right into the data tsunami of today and some really big questions about the future.
So, how did we get from ancient myths about robots to an actual field of science? Well, that brings us to the first great wave of AI, right in the middle of the 20th century, and what they called the golden years.
Picture this. It's 1956. A group of scientists get together for something called the Dartmouth Workshop. And it's here that they officially coined the term artificial intelligence. They were driven by this incredibly, almost shockingly optimistic belief. They thought that literally every single aspect of human learning and intelligence could be broken down, described perfectly, and programmed into a machine.
This whole first wave was built on an idea called symbolic AI. You might hear old-timers call it good old-fashioned AI or GOFI. The core idea was that thinking is basically just a logic puzzle. It's about manipulating symbols, like words or numbers, according to a set of rules. If you could just figure out all the right rules, you could build a machine that thinks.
And you know what? For a while, it totally seemed like they were right. The early successes were amazing. There was a program called The Logic Theorist that was proving mathematical theorems, sometimes in more creative ways than the humans who wrote it. You had Shaky the Robot, who Life magazine called the first electronic person. And then there was Eliza, the very first chatbot, which was so good at mimicking a therapist that people would spill their deepest secrets to it. It really felt like they were on the cusp of solving intelligence itself. But, and you knew there was a but coming, that incredible wave of hype was about to smash headfirst into a wall of reality. This led to the first major setback for the field, a period known as an AI winter.
I mean, the hype was just off the charts. You had leading figures like Marvin Minsky making these incredibly bold predictions, basically saying, yeah, give us a generation and we'll have this whole artificial intelligence thing solved. The expectations couldn't have been higher.
The problem was, the real world and real human thought turned out to be infinitely more messy and complex than they'd ever imagined. The early promise just hit a dead end.
So what exactly went wrong? Well, a few big things. First was a math problem called the combinatorial explosion. Basically, as problems got even slightly more complex, the number of possibilities to check just blew up, overwhelming the computers they had. But the deeper issue was the common sense problem. How do you program a computer to know that, say, water is wet, or that you can't be in two places at once? It turns out you can't just write a rule for every single piece of human intuition. It's impossible. This failure to deliver on the hype led to brutal reports, funding dried up, and AI research was plunged into a long, cold winter.
But you can't keep a big idea down forever. As the field started to thaw in the 1980s, AI re-emerged. This second wave was different. It was more practical, it was more commercial, and it was powered by a completely different way of thinking about what intelligence even is. This time around, the big thing was something called expert systems. So instead of trying to create an AI that knew everything, they focused on building systems that could be an expert in just one very narrow thing. You had systems like Mycin, which was an expert at diagnosing blood infections. These were actually pretty successful in the business world, but they had a huge fatal flaw.
Getting all that knowledge out of a human expert's head and into code was painfully slow and difficult. They called it the knowledge acquisition bottleneck.
And that bottleneck forced a massive change in thinking, a real paradigm shift. The old way, symbolic AI, was top-down. You, the human, had to handcraft all the rules. The new way, called connectionism, or what we now know as neural networks, was bottom-up. The idea was to stop programming rules and instead build systems inspired by the brain that could learn the rules themselves just by looking at tons of data. It was a completely different philosophy.
Now, the key that unlocked the power of these new learning machines was a brilliant algorithm that came along in 1986 called backpropagation. It's actually a pretty beautiful and simple idea. Here's how it works. First, the network makes a guess. Then, you measure how wrong that guess was. Step 3, you send that error signal backward through the network. And finally, the network adjusts all its internal connections just a tiny bit to make its next guess a little less wrong. You do that millions of times, and what you get is a network that learns. This one idea is the engine behind pretty much all of modern AI.
And that, right there, brings us to today. We're not in a wave anymore. We're in a tsunami. A full-blown AI revolution powered by that learning algorithm, combined with a perfect storm of massive data and unbelievable computing power.
If you want to grasp the insane speed of what's happening right now, just remember this one number: 6 months. Since around 2012, 6 months is about how long it's taken for the amount of computer power used to train the biggest AI models to double. It's an exponential curve that is just hard to even wrap your head around. And that explosion in power has fueled this accelerating pace of breakthroughs. We went from Deep Blue beating the world chess champion in '97 to AlphaGo beating the best human at Go, a game that's infinitely more complex, in 2016. And now, in the 2020s, we have the rise of large language models that can write, code, and create in ways that are just astounding. Each step is getting bigger and happening faster.
And this incredible speed leads us to our final and maybe most important section. Because this history isn't just about technology anymore. It has brought us to a critical moment in time, one that's really defined by a new and pretty intense concentration of power. Here's the core tension we're living with right now. Using AI tools is getting easier and cheaper for all of us. But creating the next generation of really powerful foundational AI models, well, that requires a level of resources that almost no one has. You need an unbelievable amount of data, you need to spend millions and millions of dollars on computing power, and you need teams of the most specialized people in the world. And today, only a handful of giant corporations can really afford to play that game.
And so that leaves us with a huge open-ended question. This entire story, from ancient Greek myths to the LLM that might be on your phone, has led us straight to this point. As these AI systems become more and more powerful and more woven into the fabric of our lives, who gets to decide what happens next? Who should be in control of the future of intelligence itself?